Today I will use spherical trigonometry to work out this problem. I am given the location of Cape Town and Buenos Aires and asked to calculate three things. Firstly, the distance along the parallel, then the distance along the great circle, and lastly, the difference between these two distances. I'm going to do a drawing first to help me understand what's going on. Here is Cape Town. And here is Buenos Aires, Argentina. In these sorts of problems, where I am asked to calculate great circle distances, I need to construct a spherical triangle. If both points are in the same hemisphere, like in this case, draw a line between each point and the nearest pole, in this case the South Pole, along great circles. These lines will follow the meridians. In the case of Cape Town, it will be the 18 degrees east meridian, and for Buenos Aires, it will be the 58 degrees west meridian. Then, join Cape Town to Buenos Aires along the Great Circle path. If I now switch on the graticule, I will see that the Great Circle path does not follow the 34 degrees south line of latitude, which both the cities are on, but goes slightly under it. This shows us that the distance along the parallel is not the shortest distance, and we will confirm this with calculation. I'm now going to draw this picture of my spherical triangle between the two cities and the South Pole. Here's Cape Town at 18 degrees east, 34 south, and Buenos Aires at 58 degrees west and 34 degrees south. And there's the South Pole. In this spherical triangle, this side will be the co-latitude of Cape Town, so chi Cape Town. This side will be the co-latitude of Buenos Aires, chi Buenos Aires. This side will be the angular distance between the two cities, let's call it Z, and this angle will be the difference in longitude, d lambda. To calculate the distance along the great circle, I will use the cosine rule of spherical trigonometry. I will leave it up to you to calculate chi of Cape Town, chi of Buenos Aires, and d lambda. Using the cosine rule, we can come up with this equation. Cos of z is equal to cos chi of Buenos Aires, cos chi of Cape Town, plus sine chi of Buenos Aires, sine chi of Cape Town, times cos of d lambda. We can solve for z in this equation, which is the unknown quantity, and z works out to be 61 degrees, 22 minutes, and 55 seconds. Z can now be converted into a distance on the globe by multiplying the radius of the Earth by Z in radians, and that works out to be 6821 kilometers. Having calculated the great circle distance, I will now calculate the distance along the latitude. If I look at the Earth from a viewpoint directly above the South Pole, I can see how the arc of parallel will be slightly above the great circle path. Along the parallel, the length is given by r times cos phi times d lambda. The phi will be the latitude of Cape Town and Buenos Aires, and d lambda is the difference in longitude. This works out to be 7,001 kilometers. So we have just proven that the distance along the parallel is longer than the distance along the great circle. And the difference between the two distances is 7,001 kilometers minus 6,821 kilometers.